Alrighty, you guys asked for it. Well, many of you did anyway, but here is your meme-themed lesson, or actually today it could be considered more of a review for our test. Well, what do you mean there's a test? Or should I say, what do you meme there is a test? Alright, so you guys said I love memes. Memes are my favorite in the words of Elf, so here we go. So if you look at that meme, it says, you said no more Edgenuity, and I said no more Edgenuity. But actually, you're right. There's only going to be 2 Edgenuity lessons this week. I've already assigned those, histograms and data displays and statistics. Other than that, we just have your 2 iReady lessons. And if you've completed those already, you're just going to be reviewing for your test, which will be on Monday. Monday, I'm going to assign a test that covers what we have done the past few weeks. And it's going to be made by myself, by me, and I'm putting it up on Edmodo. So it's not on Edgenuity or anything like that. It will be a test made by me. So this is what you need to know. Mean, median, mode, and range. You need to know how to find each of those if I give you a set of data. And then you need to understand how to find mean absolute deviation. And then the types of displays for statistics that you need to know are dot plots, box plots, and histograms. If you review all of the past videos that I've made, and you can scroll through Edmodo, they're still up there, that'll really help you study, because I'm going to look at those before I make this to make sure it's a fair test for you guys. So I hope you follow SpongeBob leads and say, I'm going to study. Shouldn't be such a hard exam for you guys, and I'm going to go through each thing right now and do a quick review, as well as you can review the past things that we've done. So, mean, median, mode, and range. If I give you this list of data and ask you to find each one of those things, let's review what you need to do. The first step, if I ask you to find the mean, is to add all these numbers together. So you're going to add 3 plus 7, plus 8, plus 2, plus 12, plus 30, plus 10, plus 8, and you should find out that all together that equals 80. So that's step 1. Step 2 is to then divide by the amount of numbers that you have. So if you look, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we have 80 divided by 8, and you will see that your mean is 10. Okay? Next question, if I ask you to find the median, your first step is to put the numbers in order. So I'm going to take this set of data and put them in order. Like magic, bam, there you go. 2, 3, 7, 8, 8, 10, 12, 30. The next thing that you need to do is figure out what's the middle. Now, because we have an even set of numbers, there's actually going to be 2 numbers in the middle. So we have 8 set of numbers. That means it's going to be 4 over here, 4 over here. My middle is right here. If these 2 numbers were not the same, I would have to add them together and divide by 2. But since they are the same, I can just say that the middle of this data is 8. There's nothing in between 8 and 8. If you wanted to add them together, 8 plus 8 is 16. 16 divided by 2 is still 8. But either way, our median is 8. So our mean is 10. Our median is 8. The next thing to do is find the mode. This is the most simple of these measures of center because the mode is just the one that shows up the most. So if we look back at our data, it's usually easiest to do this when you look at the list in order, and you can see that there are 2 number 8s. So the number that shows up the most in this set of data is just 8. So that is our mode as well. It is our median and our mode. There can be more than one mode. If I had, say, another number 2, 2 and 8 would be the mode, but in this set it is just 8. All right, last thing on this slide with SpongeBob is to find the range. The range is simply taking the biggest number and subtracting the smallest number. So again, looking at the list in order, it's easy to see that 2 is my smallest number and 30 is my biggest number. So in order to find the range, all I have to do is 30 minus 2, and you're going to see that your range is 28. Now I wanted just to review one other thing. If you look over here at my list of data, 30 should kind of stand out to you. That is an outlier. It is a lot bigger than the rest of the data. So it is making our mean bigger than the median. So if you look, we calculated that the mean was 10. If we took 30 out of this data, the mean and the median would be a little closer together. I didn't ask you to take it out, but I just want you to remember that 30 would be considered an outlier because it is considerably larger than the rest of the numbers in this set. Right, moving on. Mean absolute deviation. All right, so let's look at this meme over here, Baby Yoda and Yoda. So we started off a mean absolute deviation question looking as cute as little Baby Yoda. And then when you finally finish a mean absolute deviation question, we're looking like old Yoda there. All kidding aside, yes, I know that these are kind of lengthy, and that is why I will probably only put one of them on your test next week. But they're not so bad if you break it down. It's really just finding the mean twice, and then there's one step in the middle. So to shorten things for us right now, we're going to use that same information from the previous slide. Those are the same numbers, and we already calculated the mean of that data to be 10. So now, step 2, to find mean absolute deviation of a set of data, you need to find out how far each number in the set that we started with here is from the mean. So all we're doing essentially is subtracting. So if I look at the first number in this list, 2 is 8 away from the mean, because 10 minus 2 is 8. 3 is 7 away. 7 is 3 away. Both of these 8s are 2 away. And then this number 10, because it's the same number, that's 0 away. Now, moving on, it doesn't matter that these numbers are bigger. 12 is still 2 away. And 30 is 20 away. So now that we've figured out how far each number is, we made that new set of data, and you're going to find a mean for that new list. So essentially, all we're doing is finding the mean again, using this list now. And remember, to find the mean, you just have to add all those numbers together. If I added 8 plus 7 plus 3 plus 2 plus 2 plus 0 plus 2 plus 20, if you did that, you should see that if I add them all together, I get 44. And I still should have the same amount of numbers in my list as I had at the beginning. I started with 8 numbers here, and I still have 8 numbers in this list. 44 divided by 8. Remember, I'm okay if you use a calculator. Either way, 44 divided by 8, you're going to see that the mean of that new data is 5.5, meaning our mean absolute deviation for this set of data is 5.5. Now, what does that mean? That number shows you the spread of your data. The smaller that this mean absolute deviation number is, the smaller this number is here, that means our numbers are closer together. The larger that number is, the more spread out there are. If you were to remove the outlier from this list, our mean absolute deviation would be a lot smaller. Bart Simpson has our next meme here for you. He walking down the street saying, "Distance learning is the worst thing in my life," and Homer comes along to tell him, "The worst thing in your life so far." Such a great father Homer is. Anyways, it's not so bad, distance learning. I'm hoping that these new themed lessons are helping it make it a little bit more entertaining for you. So here we go. Dot plots. Here's a dot plot that we're going to use to explain some of the information that you need to understand. And this dot plot is representing the number of times that Homer says "do" in each episode of The Simpsons. Now, what's great about a dot plot is you can use it to find specific data. If I asked you, for example, how many episodes did I sit there and count the amount of times he said "do," you could simply look back and count all these dots and find out that there was 20 different episodes that we collected data from. On some of the other types of statistical displays, you can't get that information. Something else that I could ask you is, how many episodes did he say "do" 49 times? You could go back to the dot plot and look specifically for the number 49 and see that, all right, there were 4 episodes where Homer said "do" 49 times. Something else that you can get from a dot plot, you could get the mean, the median, the mode, and the range. The mean, you'd have to sit there and write down each one of those numbers in a list and then add them together. Like this one here is 45, you have 2 47s, and so on. The median doesn't take as much work, but to find that median, what you would do is you would cross out one dot from each side at a time. So cross one off here, then here. Keep going until you find the middle, which is going to be your median. Make sure that you don't miss any, and you're going to see that once you get to one number, that our median is here at 50. I could also use this to find the mode. That's quite simple. The mode is going to be the peak of this data. The mode is 50, so most of the time he says "do" 50 times. And then the range, which we mentioned earlier, is simply taking the biggest number, which it doesn't show here, it would be 52, and subtracting the smallest number. So it would be 52 minus 45, and you would say the range of this data is 7. Now, the other thing that you can talk about with a dot plot and some of the other plots we're going to talk about in a minute is the spread, the peaks, and the clusters. The peak is also the mode, right? So the peak of this data is 50. When we're talking about how this is spread, it's not quite symmetrical because it is skewed here to the left. When you say that data is skewed, that's the side that has the tail. So if you're looking at a dot plot or a box and whiskers plot, the side that seems to have a longer tail, that's the direction that it is skewed. So this dot plot is only slightly skewed, but it is skewed to the left. On a box plot, it would be which one has the longer whisker. All right, a cluster means that the data is grouped together. So looking at this, we have a cluster of data here. We have a gap in between, and 45 isn't really an outlier, but it is not part of that cluster. All right, so those are dot plots. Q1, Q3, this poor woman thinks that she's playing bingo, but really what we're doing is creating a box plot. So let's review what that's all about. I'm giving you this set of data, and to find a box plot, essentially what you're doing is just taking the median 3 times. So whenever you find the median, the most important thing is that you put the numbers in order first. So I've already done that for you. Bam, there you go. That's our list in order. So our first step is to find the actual median. I'm going to tell you that there's 14. You could count, but there's 14 pieces of information here. So 1, 2, 3, 4, 5, 6, 7 over on this side, and 1, 2, 3, 4, 5, 6, 7 on this side. That means that our median is going to fall right in the middle of these two numbers, 6 and 8. Since we have two numbers in the middle, to find the median, you have to add 6 plus 8 equals 14. And then you're going to divide 14 by 2 to get that the median of this set of data is 7. As I've said to you before, you could simply look at that and tell me, okay, 6 and 8, what falls in the middle? Well, 7. So our median is 7. But if you want to go ahead and calculate it, that's fine. You're going to get the same answer. All right, step 2 is to find the lower quartile, or what we also call the Q1. So that is just taking our lower half of data, which is here highlighted in yellow, and finding the median of that. So I'm going to cross off as we go, one from each side, until we get to one number in the middle. You're going to see that that lower quartile number or value is 2. And the next step is quite similar. We're going to find the upper quartile, or the median of our upper half of data. We're going to calculate it the same way, crossing off as we go until we get simply one number or 2 in the middle. Oops, I circled both of those numbers. It's just this one here. And our upper quartile value is 9. And then your last step is the easiest step, actually, to find your lower and upper extremes. All you're doing is finding our lowest value and our highest value. So our lower extreme is 1, and our upper extreme is 12. Once you have those 5 pieces of information, creating a box plot is quite simple. And for you guys, you're not actually going to have to draw one. You're just going to have to understand what each of these are on a box plot. So this is what it would look like. Here's our box plot. This box represents our interquartile range from here to here. 50% of your data falls in this box. Here's your lower extreme, which was at 1, your upper extreme, which is at 12, our median was here at 7, and our Q3 or upper quartile was here at 9, and our Q1 was here at 2. Now remember, to find the interquartile range, or the IQR, you just simply subtract your upper quartile value and your lower quartile value. So if I were to ask you, I'm going to write up here at the top, what is the IQR, the interquartile range of this data? All you would be doing is 9 minus 2, which is 7. So that's your interquartile range for this set of data. Relax! The squirrel is telling you to relax. This is the last slide. I know this is kind of lengthy, but this is your review for the last so many weeks. Your last information that we learned about was histograms. So they are similar to a bar graph. Really, the only difference is that it uses intervals instead of categories. Those intervals must be equal, they must be in order, and the bars on your graph must touch. If they're not touching, like you see here, that means that there's no data. That's 0. So let's talk about what this particular histogram represents. If we look at our labels on our x-axis, we see that we're talking about the toilet paper rolls left, and over here shows you this is the amount of Leawood staff. So breaking it down, if I asked you, for example, how many Leawood staff members have between 0 and 3 toilet paper rolls left, well, we would find that interval here and see, if we look at this bar, which represents the frequency, that 4 teachers have only 0 to 3 toilet paper rolls left. They are in trouble. Now, if I asked you how many faculty members did we survey, you could find that out with this histogram. Remember, you couldn't see that on a box and whiskers plot, but you can see that on a histogram. So there's 4 individuals that have 0 to 3 toilet paper rolls left. The next interval, which is 4 to 7, there's 8 people. There's also 8 people that have 8 to 11. There are 10 people that have 12 to 15, 6 people that have 26 to 29, 2 people have 20 to 23, nobody has 24 to 27, and then you have these 2 really lucky people over here who have 28 to 31 rolls of toilet paper left. So if you wanted to know how many total Leawood staff members I surveyed to get this data, we would just add all those together. So 4 plus 8 is 12, plus another 8 is 20, plus 10 more is 30, plus 6 is 36, 37, 38, 39, 40 staff members were surveyed. The other information that we talked about with a box plot can apply here too. If I asked you for the peak of this data, you're just looking for where is the highest point, and the peak is here. There are 10 people that own 12 or that have 12 to 15 rolls of toilet paper left. That's your peak. This here would be a cluster. Like we mentioned before, this area here where there is no data, let me highlight it for you. This would be a gap, where that gap means that there was nobody surveyed that had 24 to 27 rolls of toilet paper left. All right, I hope this was a good review for you. Keep those theme ideas coming and study for your test next week.